Okay, hi guys, Assalamualaikum. So hari ni kita akan cuba habiskan topik 4.2 iaitu Molecular Geometry. So for the last part of this subtopic, we are going to have a look at repulsive forces. Okay, daya tolakan. So basically, we have three types of repulsive forces. So the first one is bonding pair. Okay, second is lone pair, bonding pair, repulsion. Third one is lone pair and lone pair, repulsion. Okay, so let's have a look. Contoh bonding pair repulsion adalah methane. Why? Because for methane, kita tahu bentuknya adalah tetrahedral. And this is the bonding for tetrahedral. Okay, repulsion for methane kat sini adalah between bonding pair and bonding pair. So these two, okay, all of this actually dia akan tolak menolak antara satu sama lain. So that's why you dapat bond angle 109.5 degree. Okay. So, second example is lone pair and bonding pair repulsion. Okay, contoh paling simple adalah ammonia. Okay, so in ammonia, we have lone pair and bonding pair. So, bonding pair and lone pair, they will repel one another. Okay, so kalau kita tengok, the repulsion between lone pair and bonding pair are greater compared to bonding pair. Okay, so that's why, okay, for methane, we know that the bond angle is 109.5. Okay, so for ammonia, okay, for lone pair versus bonding pair repulsion, okay, so maksudnya the repulsion is between the lone pair and the bonding pair. Okay, so due to the presence of the lone pair, the repulsion becomes greater. Okay, because of that, bond angle decrease. Okay, bond angle makin kecil lah sebab tolakan dia makin kuat. So, the bond angle for ammonia, originally ammonia's geometry should be tetrahedral. But due to the presence of the lone pair, so the shape now is trigonal pyramidal. And the bond angle for trigonal pyramidal for ammonia is 107 degree. Okay, kita dah specific bond angle dia adalah 107. Okay, so cuba you compare this one and this one. Okay, so now bond angle smaller. Okay, next, let's have a look the repulsion between lone pair and lone pair. Okay, so the simple example is water. So we know that water consists of two lone pair and two bonding pair. Okay, so kita anggap saja lone pair tu tak wujud. So the shape of water is bent. Ataupun boleh juga kita guna V shape. Okay, so in water, we have lone pair and lone pair. So the repulsion between lone pair and lone pair sangat kuat mengakibatkan bond angle untuk air jadi makin kecil. So for water, the bond angle is 104.5 degree, not degree Celsius. So we can conclude here that the repulsion between lone pair and lone pair are greater compared to lone pair bonding pair, and lone pair and bonding pair repulsion greater than bonding pair and bonding pair repulsion. Okay, so macam mana kita nak explain? How to explain this situation? Okay, let's read one by one. Okay, the repulsion between lone pair and bonding pair is stronger. Lone pair bonding pair is stronger. Lone pair bonding pair refer to ammonia lah. Okay, stronger than repulsion between bonding pair in methane, CH4. Okay, so make them highlight supaya you guys nampak. The electron pair around central atom will repel one another and arrange themselves as far apart as possible to minimize the repulsion. So basically this statement adalah VSEPR theory. Okay, sambung. Thus, the angle is reduced approximately 107. Okay, so less than 109.5 lah. Okay, next, the repulsion between lone pair and lone pair is stronger. Lone pair is stronger in water than the repulsion between lone pair bonding pair in ammonia. Sekarang kita banding ammonia dengan air pula. Okay, so this one samalah. Repel one another to minimize the repulsion. So basically, this is Vesper theory. Okay, disebabkan atom tolak-menolak antara satu sama lain tu, bond angle decrease approximately to 104.5 degree. Okay, so that's how we explain the situation lah. Tapi untuk fahaman awak semua, okay, kat sini kita nak cakapnya bahawa repulsion antara lone pair lagi kuat berbanding lone pair and bonding pair. That's why bond angle lagi kecil. Okay, so that's the repulsive forces inside molecule. Okay, next, let's move on to bond polarity. Okay, polarity adalah bermaksud kutub, kekutuban. Okay, the definition is bond polarity is the difference in electronegativity between two atoms in covalent bond. Okay, so kita tahu in covalent bond, electron are shared between two atoms. Okay, if the atom sharing are equal, for example, Cl and Cl, and we know that both are electronegative atom. So, if the sharing of electron is equal, the electron cloud will look like this, sekata. Okay, but if the sharing of electron are not equal, contoh, oxygen, hydrogen. We know that oxygen are more electronegative than hydrogen. So, maksudnya kat sini, electron will spend more times sekitar oxygen. So, that's why electron cloud lagi besar, okay, di bahagian oxygen. Okay, now let's have a look. What is meant by non-polar bond? Okay, non-polar bond are formed when two identical atoms are joined together. For example, fluorine. Okay, so these two atoms are all electronegative atoms. So kita tak boleh tentukan which one delta positive, which one delta negative. Okay, since fluorine atom here have the same electronegativity, okay, so the bond here, tukar pen jap. The bond here are non-polar bond. Okay, so kalau soalan tanya, why bond is non-polar? Sebab both atoms have the same electronegativity. Okay, let's move on to polar bond. So polar bond is formed when two different atoms are joined together. For example, HF. Okay, so kita tahu fluorine is more electronegative than hydrogen. So, maksudnya elektron lebih tertumpu, electron are concentrated on fluorine side. Okay, so the bond now is polar bond. Maksudnya dia ada kutub. Okey, dia ada kutub utara, kutub selatan. Okey, awak belajar magnet kan? Okey, madam tunjuk contoh magnet. Dalam magnet ada kutub utara, ada kutub selatan. So, molekul pun macam tu. Okey, so contoh carbon fluorine. So, these two atoms ada kekutuban dia. So, katakanlah fluorine kutub utara, carbon kutub selatan. Tapi kita tak panggil kutub utara, kutub selatan lah. Kita panggil elektronegatif, elektropositif. Okay, so that's the difference between polar bond and non-polar bond. Okay, let's do example 1. For HCl molecule, okay, which atom is more electronegative? Okay, so we draw the HCl molecule first. Okay, after that, you have to determine which one electronegative. So, between hydrogen and chlorine, kita tahu chlorine is halogen. Halogen, okay, group 17 tu, semua atom dia adalah electronegative. So, automatically, tak payah fikir. Hydrogen automatically akan jadi electropositive. So, to answer this question, which atom are more electronegative? So, the answer is chlorine lah. Okay, next, what charge each atom has? Okay, so hydrogen, is positive 1 charge, chlorine is negative 1 charge. So, is the bond polar? So, the answer is yes. Okay, tapi soalan tak suruh explain kan? Tapi kalau soalan suruh explain, why? Because there's difference in electronegativity between two atoms. Okay, so after this, tak perlu fikir banyak, nampak sahaja. Once you see the halogen, so automatically halogen is delta negative. Halogen is electronegative. Salah pula macam ni, delta minus. Okay, so let's do example 2. Classify the following into polar or non-polar bond. Explain. Okay, let's do for A first. For A, the bond given is the bond between C and N. Okay, as I told you so many times already, in the periodic table, FON. Okay, fluorine paling elektronegatif lah. Okay, selepas fluorine, oxygen and nitrogen. So basically nitrogen is electronegative compared to carbon. So carbon akan jadi electropositive lah. So is the bond polar or not? So the bond is polar lah. Polar bond. So why polar bond? Macam tadi. This is the reason. Okay, because there's a difference in electronegativity between two atoms. Okay, next we do B. We do B. So we have chlorine. So basically the atom is the same thing, the same atom. So since the atoms are the same, so the bond is non-polar lah. Non-polar tu maksudnya tidak ada kekutuban lah. Tidak ada delta plus, tidak ada delta minus. So explain your reason. So basically the molecule is non-polar because cakap je macam tadi, cuma you explain there is no difference in electronegativity between atom. Okay, so senang saja. Last one, C. Obviously, there's a two different atom over here, and oxygen is more electronegative than carbon. Okay, so automatically the bond is, yes, polar bond. So why the reason? Okay, refer pada angkat atas ni lah. Okay, so basically that's how we answer this kind of question. Okay, next, let's move on to dipole moment. So, dipole moment is a measure of how polar is molecule. So, kita tahu polar ni maksudnya dalam molekul tu, between two atoms, there's a delta positive and delta negative. So, kita akan tengok dipole moment pula. So, dipole moment is a measure of how polar the molecule. So, calculation is not required. So, yay. However, you have to know that if mu equals to 0, molecule is non-polar. If mu is not equals to 0, molecule is polar. Okay, nak betulkan sikit penulisan dia. Mu ni macam gini. Okay, that's the symbol for dipole moment. So, this symbol equals to the symbols of dipole moment. Okay, now let's move on. Bond dipole. Okay, bond dipole are represented by this arrow. Kita ada arrow straight, and kita ada dia punya macam kaki kat belakang tu. Okay, so the direction of arrow show us where's your electron density. Okay, so kalau kita jumpa atom nanti, this is delta plus, and dekat kepala tu adalah delta minus. Maksudnya electron shift from electropositive to electronegative atom. Okay, kita tengok contoh. For carbon and nitrogen. Okay, so we know that nitrogen is more electronegative than carbon. So, the direction of the arrow is from carbon to the nitrogen. So, that's how we do it lah. Okay, next, S and O. Okay, so for your information, sulfur and oxygen belongs to the same group, which is group 16. However, sulfur is below than oxygen. So, maksudnya oxygen lagi kecil lah. So, kita tahu lagi kecil atom tu, electronegativity dia tinggi. So, between sulfur and oxygen, oxygen is more electronegative than sulfur. So, the direction of the dipole moment is from sulfur towards oxygen. Okay, next, move on. Oxygen and fluorine. Okay, madam dah bercakap banyak kali. Fluorine is the most electronegative atom. Okay, fluorine is the most electronegative atom. So, madam tulis lagi sekali ya, macam tak jelas. Okay, this one. Sepatutnya macam ni ya. Delta minus, delta plus. Okay. So, the direction of the dipole moment is from oxygen to fluorine. Okay, last one, nitrogen and hydrogen. So, obviously lah, nitrogen is more electronegative than hydrogen. So, the direction of the dipole moment is from electropositive towards electronegative atom. So, pentingnya untuk you tahu direction ni sebab kita nak tahu polarity untuk sesuatu molekul. Okay, now resultant dipole. So basically, jangan tertukar. Dipole moment is a measure of how polar your molecule. Bond dipole show us the movement of electron, which is from electropositive to electronegative atom. Okay, next kita akan tengok resultant dipole. Resultant dipole ni maksudnya hasil tambah dipole. Okay, for example, if our dipole moment, one up here, another is horizontal, vertical, 90 degree. So the resultant dipole, awak belajar fizik kan, should be in the middle. Okay, so in this case, the dipole moment is not cancel each other. So mu is not equals to 0 because the dipole moment, arrow ni adalah dipole moment. Kita buat nota sikit. This is dipole moment. Okay, so mu is not equals to 0. Okay, next let's have a look at B. Cuba tengok direction arrow tu satu ke kiri, satu ke kanan. Let's say this one, the value is positive 10. Kalau ke kiri, negative 10. So, if we add up these two together, so basically mu equals to 0. So, molecule is non-polar. Yang ni tadi molecule polar. Okay, tengok yang ni tadi. This one. Okay, continue. Last one. Let's say if you only has one dipole moment. Okay, so basically this one, dipole moment, not cancelling lah. So means that your molecule is polar. Okay, now let's have a look at example 4. The question asks you, is the Cl-Cl bond polar? Okay, kita dah jawab tadi ya. So basically Cl-Cl bond is non-polar. Okay, B, is the molecule polar? No. Molecule is not polar. Okay, kita tengok. Sekarang kita akan gabungkan konsep dipole moment, bond dipole dan juga resultant dipole untuk kita cari polarity sesuatu molekul. Okay. Polarity of molecule depends on molecular geometry. Okay, and the sum of all dipole moments. Okay, so if molecule contains all non-polar bonds, so maksudnya molekul tu adalah non-polar molekul. Contoh ClCl. Okay, klorin tadi kita tahu bond dia kat sini tadi is non-polar bonds. So disebabkan bond itu non-polar, so maksudnya Cl2 ni adalah non-polar molekul. Okay, so now kita akan tengok dua situasi di mana if the molecule contains polar bond, dia boleh jadi polar molekul ataupun dia boleh jadi non-polar molekul. So kita akan tengok Okay, kita tengok contoh teruslah baru nampak. Okay, so example 1 is CO2 polar. Explain. Okay, dekat bawah ni madam ada letak step. You just follow the step. So step 1, we draw the Lewis structure. So I already draw it for you. Draw the molecular geometry. Okay, for your information, the geometry for CO2 is linear. Okay, carbon dioxide is linear. Which is, kita tahulah kalau linear, bond angle is 180. Okay, so cuba kita lukis dia punya bond. Kita lukis dia punya dipole moment. Okay, nak lukis dia punya bond dipole, kita kena tahu electronegativity. So kita tahu oxygen is more electronegative than carbon. So you label dulu which one electropositive, which one electronegative. After that, you draw the bond dipole. Sini ke sini, sini ke sini. Okey, cuba you tengok the bond dipole, the resultant dia akan jadi kosong lah. Kenapa? Sebab dia berlawanan arah. So basically, for example 1, okay, so CO2 is non-polar molecule. Okay, why? Because Dia tulis dulu dipole moment cancel each other. Okay, so mu is equals to 0. So that's how we answer this kind of question. Okay, next let's have a look at more example. Okay, ada banyak example kat sini. Okay, is CCl4 molecule polar? Explain. Okay, so for your information, first, you kena lukis dulu shape untuk first you kena draw dulu Lewis structure. So from the Lewis structure, we determine the shape. So since kita dah tahu shape dia tetrahedral, so you should draw it as tetrahedral. So after that, you determine which one electronegative, which one electropositive. So Madam dah bagi tahu tadi, halogen are more electronegative compared to carbon. So draw the dipole moment. Yeah. Okay, so now the dipole moment are coming out from carbon towards chlorine. So even though nampak macam cancel out, tapi the angle is not exactly macam CO2 tadi. Okay, bond dipole only cancel out if the bond angle is 180. Okay, now kita tahu tetrahedral punya angle is not 180 kan? So for tetrahedral, the bond angle is 109.5. Okay, means that for this one, dipole moment, dia akan jadi dekat tengah-tengah tu. Okay, so for this molecule, the answer is CCl4 is polar. Why? Because dipole moment are not cancelling each other. So mu is not equals to 0. Okay, guys, try to do on your own. Example 3 until example 7. And also try this 2. Try this 3. Try to do on your own, and we are going to discuss this on Tuesday. Okay, I think that's all from me. Okay, see you guys soon. Bye-bye.